All right, hello, good afternoon. Geometry, this is the first lesson in section 5.1 for geometry class. It is called 5.1 perpendiculars and bisectors. I've got 4 boxes for you. You need your construction materials, so like a straight edge and a compass. I'm going to start with a warm-up over here on the left-hand side of the guiding questions. It says, using a straight edge, copy the diagram and label the information below. So I've already done it for you, so I'm just going to talk about it. I have this triangle here. It says number 1, angle C is a right angle, so I put the angle C labeled right there as right angle. I have angle A is congruent to angle B, so I have angle A and angle B congruent to each other. I have AB as a side length of 8, so I labeled AB with a side length of 8 right there. And then I had AD bisects CB. So bisecting means that those two segments are congruent. And that leads us into what this section is all about. So box number 1 here is the idea of a perpendicular bisector. So a perpendicular bisector has to fulfill the 2 words that it says. Perpendicular, which means it meets at 90 degrees, and bisect means it cuts a segment in half. So if you have those 2 things going on, you have a perpendicular bisector. So we drew a line with a ruler, and we labeled it AB. We measured it. Mine was about 10 centimeters, or I called mine about 10 centimeters. So I found about 5 centimeters halfway through. We constructed perpendicular bisector, and I said that. Oh, go away. I said that CP is the perpendicular bisector of AB. So CP is this part right here. It is the perpendicular bisector of this line segment AB. So there's the idea of what a perpendicular bisector is. Pretty straightforward. Box number 2 was a construction, and here's the video that we're going to watch for the construction. So we watched this, basically. We have, this is a great website, by the way. It's called mathopenref.com. So if you get a chance to check it out. Anyways, we're constructing a perpendicular bisector here. Shows you how to do it. We actually did this in class together. And everyone should have that in their notes, and there you go. So that's pretty sweet right there. So check that out, and there's also a link to my on our page. All right, so box number 3 here gets into some theorems now. Okay, box number 3 is 2 theorems, theorem 5.1 and 5.2. We're going to put these in our toolkits tomorrow. I will give you toolkits tomorrow. We'll put them in there. Theorem 5.1, the perpendicular bisector theorem, says this. It's an if-then statement. So it says if CP is the perpendicular bisector of AB, so I have CP, perpendicular bisector of AB, then it's true that CA is equal to CB. These distances are equal to each other. That's theorem 5.1. Same distance from the endpoints there. Now, theorem 5.2 is the converse of that. So the converse, of course, we learned back in chapter 2, I think it was, we switched the if and the then statements. So if we know that CA is equal to CB, then it must be true that CP must be the perpendicular bisector of AB. So we have those 2 rules, theorems. We're going to put them into our toolkit on Monday. I have a guiding question over here on the left-hand side. It says, what does the perpendicular bisector theorem say? Something you should look up and make sure you have in your toolkit. All right, we've got one example here. And if this is going too fast, and you can pause the video and go back and go over it. Example number 4 here. It says, in the diagram shown, PQ is the perpendicular bisector of CD. So P to Q, perpendicular bisector of CD. Part A says, what segment lengths in the diagram are equal? So here's what we know. We were given that CT is equal to DT. We know that since it's the perpendicular bisector, QC is equal to QD, and we also know that CP has to be equal to DP. So I wrote those all down right here, 1, 2, and 3 over here. So here you go. What is true about any point in the perpendicular bisector of a segment? That it is equidistant from the end points. So if C and D are the end points, they're equidistant. And there you go. And it says, explain why T is on PQ, and what theorem says so. Well, we know that CT is equal to DT, so that tells us that it must be the perpendicular bisector, so theorem 5.2 allows us that. Okay, I'll put these notes up for you so you can download them, and your homework is right there, page 267, 1 to 13 all. Okay, see you guys tomorrow.